Section 7.6 is on natural logarithms. The inverse of the function y equals e to the x is called the natural logarithmic function. It's written as y equals log base e of x, or y equals the natural log of x, and we abbreviate that ln. All of the properties of logarithms that we saw in previous sections also apply to natural logs. Two very useful properties are e raised to the power of the natural log of x is equal to x, and the natural log of e to the x is equal to x. And we will use these in solving equations that involve natural logs. Let's take a look at a couple examples here. Here we need to write each expression as a single natural log, using the properties that we saw in the previous section. So 3 times the natural log of 2 minus 3 times the natural log of x. First thing I'm going to do is take that coefficient and make it an exponent. So this is going to be equal to the natural log of 2 to the third minus the natural log of x to the third, and 2 to the third is 8. And because I have subtraction, I can write that as a single natural log using division. So that's going to be equal to the natural log of 8 over x to the third power. My second example is 2 times the natural log of 3 plus the natural log of 8. So again, I'm going to move my coefficient to as an exponent, so this becomes the natural log of 3 squared plus, and I can't really do anything with the natural log of 8, so I'm just going to leave it right there. So this is the natural log, the natural log of 9 plus the natural log of 8. And remember the property that says if I have addition, I can write it as multiplication. So this is going to be the natural log of 9 times 8, or the natural log of 72. To solve equations involving natural logs, we're going to do one of two things. Depending on what we're given, one way we can solve it is to take the natural log of each side of the equation, or we can make each side of the equation an exponent of e. We'll take a look at an example of each of those. First example, solve this equation, check your answers. We have the natural log of the quantity 3x plus 5 raised to the second power equals 4. Because this involves a natural log, I can make both sides of the equation an exponent of e. So e raised to the power of the natural log of 3x plus 5 squared is equal to e to the fourth. And remember the property that says e raised to the power of the natural log of x is equal to just x. E raised to the power of the natural log of 3x plus 5 squared is equal to just 3x plus 5 squared. And leave this as e to the fourth. Remember, e is not a variable, e is actually a number approximately equal to 2.718. Okay, now I need to solve this for x. So I will take the square root of both sides, give myself a little more room here. So that's going to be 3x plus 5 equals plus or minus, and the square root of e to the fourth is e squared. And now I'll subtract 5 on each side. So 3x equals negative 5 plus or minus e squared, and then divide both sides by 3. Negative 5 plus or minus e squared all over 3. And when I plug that into my calculator, I get that that's approximately equal to 0.7964, or negative 4.1297. Because of that plus or minus, we are going to end up with two possible answers. And I would check this by plugging it back into my calculator for x and see if the left-hand side isn't going to be exactly, because these are approximations, but it should be approximately equal to 4. And our last example here says e raised to the power of 3x plus 5 is equal to 15. First thing I'd like to do is get e all by itself, so I'll go ahead and subtract 5 on each side. So e to the power of 3x equals 10. And now I'll take the natural log of each side. The natural log of e to the 3x equals the natural log of 10. And remember the property that said the natural log of e raised to any power is equal to just that power itself. So the left side of the equation becomes 3x equals the natural log of 10, and then dividing both sides by 3, I get x equals the natural log of 10 divided by 3. Now that is an exact answer, but if we plug that into our calculator, we get that that is approximately equal to 0.7675. So in this section, we took a look at the natural logarithm, which is the inverse of the function y equals e to the x, saw how the properties of regular logarithms apply also to natural logs, looked at a couple of useful properties, and then how to use those to solve equations that involve natural logs or e.